Hello, Mr. Betts here. In this example, we want to evaluate a definite integral for a function that is a piecewise defined function. And if you remember our properties of definite integrals, essentially what we can do is we can split the integral up into two integrals at 0. So we can evaluate this integral from -1 to 0 and from 0 to 3. And evaluating those integrals separately, we can do that because from -1 to 0, the function is less than 0 is going to be x squared plus 1, and from 0 to 3 is going to be e to the x. Now I do want to point out that 0 is not included here, and that's okay. Because if we're talking about area, the area under the e to the x function, which looks like this from 0 to 3, it doesn't matter if this point is included or not, this area is going to be the same. So we can split up a piecewise function, an integral with a piecewise function, at the boundary for the piecewise function, and then evaluate them independently. So evaluating the first one, antiderivative of x squared is x cubed over 3 using the power rule. Antiderivative of 1 is x, and we're evaluating that expression from -1 to 0. And then the antiderivative of e to the x is e to the x, and we're evaluating that from 0 to 3. Now, this is a problem where the grouping symbols are particularly important because if we're not using them appropriately, it may seem like we're evaluating this entire expression from 0 to 3 instead of just the e to the x. So make sure that your work is clear and there's no ambiguity about what applies to what. In fact, it might even be a good idea to, even though we don't have multiple terms here, use the brackets to make it clear that 0 to 3 only applies to the e to the x. Now we need to plug in the values. So we've got, plugging in 0, we have 0 cubed over 3 plus 0. Okay, all of that's 0. We could have saved some time by just not writing that. Minus -1 cubed over 3 minus 1. And then plus e to the third minus e to the 0. If this is a free response question, this is perfectly acceptable. There is some simplifying that we could do if we had to. So for example, e to the 0 is 1. All of this here drops out. So we do get a simpler answer by simplifying, but again, this answer here for free response is perfectly fine.